through the 5 or 6 questions that we didn't get through in discussion today. I'm working with a computer program. The writing isn't super great, so please forgive me and give me some grace as we work through these questions together. I know it's not ideal, but this is the best thing I could think of with the amount of time. So let's jump into this question. We're looking at a pressure and volume problem. When I see pressure and volume, I'm going to go ahead and automatically think of Boyle's law, which is P1 V1 equals P2 V2. Okay. Outside of remembering the equations, the only thing that's left after that is plugging and chugging. I know that I'm working with pressure and volume because I see the unit kPa, that stands for kilopascals. I also see the unit of L, which stands for your liters, so I know without the use of this header that I'm going to be using this equation. From there, I just got to distinguish what's my first pressure, what's my second pressure, and then what's my first volume. So in this case, we start off with that first value is 2.5 liters. I'm going to leave out the units in all of these just because it's kind of annoying to use this system. But in your notes and or homeworks, you can include all those units. We start at a initial pressure of 105 kilopascals. And we are going to change that, decrease that pressure to about 40 kilopascals. Okay. If you decrease your pressure, you kind of have an idea that your volume is going to increase. Just by how much is what this math is going to tell us. Now, I had said that you may need to do some unit conversions, but in this case, since it's more of a ratio type of thing, we can just leave all the units as they are. We are also not using the gas constant, so we don't necessarily need it in atmospheres or any other unit for that matter, okay? So I'm trusting that you guys know how to solve this. You're going to multiply these two together, divide by 40.5. V2 is going to give you an answer of 6.48 liters. So that's that first question. We're going to move on to the second one. With this one, now we are looking, that's not what I wanted to do. Now we're looking at our pressure versus our moles, which is one of the laws we talked about today. With this one, we want to see what happens to the pressure if you increase the number of moles. Okay, in your head, you can already be thinking, I am going to be getting a pressure value that's greater. The more moles you have, the more collisions. The more collisions you have, the higher the pressure. Okay, with this one, we talked about this one in discussion today. P1 over N1 equals your second pressure over your second number of moles. From there, our first pressure is 1.5 atmospheres. That's over 10 moles. We're going to increase those moles to 18, and we're going to solve for P2. Cross multiply and divide, and you get a pressure value of P2 equal to 2.7 atmospheres. The next one we have, now we're looking at pressure and temperature. If I start at 148.5 kilopascals, and that is at 23 degrees Celsius, what is the pressure of the can once we heat it? Now, with this one, you do want to convert your temperatures over to Kelvin. When we're working through these other types of equations, you don't have to do unit conversions, but you always have to do Kelvin unit conversions, just in case there happened to be a negative temperature that pops up along the way. Get in the habit of putting it into Kelvin. What is the pressure? If we start at 148, this equation, by the way, is I'm going to write it down here, P1 over T1 equals P2 over T2. So I'm starting off with 148 kilopascals. That's at 23 degrees Celsius. I'm going to add 273 onto that to get a Kelvin value of 296. And I am looking for the new pressure, P2, once I heat that can up. When I heat that can up 7 degrees, now I'm sitting at about 303 degrees Kelvin. Again, you're going to cross multiply and divide, solving for P2. That is going to be 152 kilopascals. Again, I don't have to do any unit converting because I get a pressure value since it's a ratio. If it asks me to put it in a different unit, then I could convert that easily. So 152 kilopascals is your answer for that one. Now we're moving on into our volume and our temperature. Volume and temperature is looking at Gay-Lussac's law. Gay-Lussac made the connection between the two, that in order to keep the constant pressure, if the temperature increases, your volume has to increase as well. So in that case, we are looking at the fact that V1 over T1 equals V2 over T2. Our initial volume is our 88 milliliters. That is over our initial temperature. Remember, we want to convert this to Kelvin. This happens to be 308 Kelvin. We are looking for our second or final volume, and it is over 428 Kelvin. Again, cross multiply and divide by this value. You are given or ultimately get a value of V2 equal to 123 milliliters. Therefore, again, proving that when you increase your temperature, you got to increase that volume as well if your pressure needs to stay the same, which in this case it does. All right, moving over into Avogadro's law. Avogadro's law relates your pressure, not your pressure, your number of moles to your volume. Okay, so this is an instance of where I was talking about today. If you know the overall equation, you can manipulate it into the things that you need. So our combined gas law, if you remember, P1V1 equals N1R times T1. And we can set that equal to P2V2 over N2R and finally T2. We did not talk about Avogadro's law in class. However, it is an example of what I was trying to communicate about being able to figure out what variables you need once you have this all put together. Our question says nothing about pressure. So I'm going to take that out of my equation. I'm not going to do anything with my pressure. My question says nothing about my number of moles, so I'm going to assume that's the same on both sides. R is the same on both sides. Sorry, we do need our moles. That was dumb. Okay. What I meant to say was that our question says nothing about our temperature. So we do need our moles. We don't want to cross those ones out. I'm going to put those back in there. Okay, so N1 and N2. What I meant to say is we do not need our temperature, so I'm going to cross that out. When you take out the variables you don't need, all of a sudden you are left with the relationship of the ones that you do. So even though we did not specifically say, hey, this is a law in our previous slide, we can take out those variables and figure out how we're going to solve this. All right, so we start with 0.11 moles of substance that reacts to form 0.58 moles of substance. If my initial volume is 2.1, what effect on increasing the number of moles will happen on my V2? So ultimately, again, you're going to cross multiply and divide, solving for V2 after you increase the number of moles. And that is going to, what you would expect, give you a higher amount of volume. And that answer is 11 liters. Okay, so that is an example of how to use the whole combined question. All right. This last question is an example of our STP, or calculations at STP. STP, remember, is standard temperature and pressure. That is 273 degrees Kelvin and 1 atmosphere of pressure. A balloon has an initial volume of 3.7 liters at a pressure of 4.7 atmospheres and a temperature of 15 degrees Celsius. What will its volume be at STP? Again, this is another version of your combined gas law. We are going to only keep the variables that we need in this question. I'm going to write it all out again, and then we'll go through and cancel the variables we don't need. Into R, and finally T2. Okay. I'm given a volume, so I'm going to keep my volumes. I'm given a pressure, I'm going to keep my pressures. I do not need my moles, as that's the same on both sides. And because this value is going to be the same, I'm going to not even use my 0.0821. Okay, I'm going to be dividing or multiplying by that on the same side. So what we're looking for now is the fact that we start with 4.7 atmospheres of pressure and 3.7 liters of gas. Sorry, that should be a 7. That is at 15 degrees Celsius, so I'm going to convert that over into Kelvin. You get 288 Kelvin. And we want to put that at STP. STP tells us that we're going to change that pressure over to 1 atmosphere. We're going to change our temperature to 273 degrees Kelvin, or Kelvin, not degrees. And ultimately, we want to figure out what our new volume will be. So we need to solve for V2. I trust that you know how to solve for that, but you're going to divide these on this left side, multiply it by 273, and then divide by 1, and that'll isolate your V2 for you. V2, so you can follow along with your own calculations. Make sure you're typing it into your calculator right, is 16 liters. All right, guys, hopefully that helped a little bit. Mastering is due at 8 a.m. on Thursday morning. Mrs. Barquette should be able to help you Wednesday, or send me an email. I'd be happy to get you some help. Okay. All right, I'll see you guys all on Thursday.